Login acceptance.
Hello. Thank you very much for being here in this talk, Machine Learning with Java, Deeplearning4j. My name is Enrique Llerena Dominguez. I am a senior software engineer at mimacom in Germany. I have experience developing software for different kind of industries for already like 13 years. I like to learn about software architecture. I like to learn about cloud computing and artificial intelligence. And during my free time, I like to spend some time with my kids and to learn German and, of course, developing some nice things. Here is how you can contact me at Twitter, GitHub, my personal email, and visit my blog at ienjoysoftware.dev. This is from my employer. This is an event that we had in Mallorca like 2 years ago. All the countries gathered there. We had a nice weekend. And we are hiring in Germany, Spain, Switzerland, and the US. So join us. So now let's come to the business. What are we going to look today? The agenda is we're going to look at some basics of machine learning and what Deeplearning4j is. We're going to look at some of the integrations that Deeplearning4j provides, and we're going to have some hands-on examples, concretely talking about image classification and sentiment analysis. We're going to see the approach, how to solve this, and of course, the most important thing, the most interesting thing, the code. So, what is machine learning? Machine learning is a study of computer algorithms that improve automatically through experience. The idea is that if you have a labeled data set, we can process it in such a way that it will find a mathematical function representing the relationships between the data and the label. And later, we can use such mathematical function to predict the label based on the data that we have. So now, what is Deeplearning4j? It is an open source deep learning library written for Java and Scala and other JVM languages, and it is under the cover of the Eclipse Foundation. So now, to have a look at the basics of machine learning, let's have a story. It's about the iris classification, the iris dataset, also known as the machine learning hello world. So there was this guy, Peter the biologist. He used to live in Canada, in this Gaspe Peninsula. And there, these flowers caught his attention. They found them particularly beautiful, so he started studying them. He called them the iris virginica, the iris setosa, and the iris versicolor. And in order to classify them, he started measuring the sepal and the petal. So he created a data set and with the different measurements and with which class they corresponded to. So later, during dinner, at his camp, he liked tacos. Anyway, he was, I don't know why, because he was in Canada, but he liked tacos. So during the dinner, he told to his kids, it would be really cool that someone else could classify these flowers just by providing the measurements. And guess what? He had a daughter, and she was software engineer. She is software engineer. Her name is Teresa. And she said, hey, I can automate that. Of course, software engineer DNA, right? But first things first. So now let's start hacking some code. What are the resources that she has? She has the labeled data set that his father created earlier with the measurements of the flowers. She knows Java. She has Maven for managing her dependencies, and he's learning this thing, Deeplearning4j. So looking at the problem a little bit more formally, it is of type classification. She has 150 instances, rows, and she has 4 attributes on each row: the length and width of sepal and petal. And she has 3 classes, the 3 types of flower that her father found. So now, there are 2 big steps, let's say 2 big phases during the machine learning process. One is the training step, and the other one is the prediction step. The idea is that on the training step, you get the data set, you process it with something, in this case, Deeplearning4j, and then you will get this mathematical formula that you will use later on the prediction step. So you feed data to this prediction step, and then you get the prediction. Now let's dig deeper into the training step. These are the things that we need to do for this step. First, we need to load the data set. We need to normalize the data. We need to split it in train and test data sets. We need to configure the model. We need to train it. We need to evaluate it. And then we need to export it for the next step. So now let's look at the most valuable code. So first, we load the data set. Here we are using a CSV recorder, record reader, which is provided by one of the dependencies of Deeplearning4j. And in this case, we are reading everything into memory because we just have 150 instances. It's not that much. We can just go directly and read everything. After that, we're going to normalize the data. Normalize the data means putting all the numbers in the range of, for example, 0 to 1 or -1 to 1, so that big numbers in certain features do not affect that much small numbers in other kind of features, or the other way around. So here we use this normalizer provided by Deeplearning4j. We fit it, and then we normalize the data. After that, we split our data set into test and train. The idea is that we will use the train data set to create the model, and after that, we will provide it with data that it doesn't know, so that we can know the different metrics of how well it performs. So now, in order to configure the model, we will create a neural network. It has 3 layers. And the most important part here are the input layer and the output layer. The input layer needs to have the same amount of nodes that the amount of columns that we have. And the output layer needs to have the same amount of nodes that as much as classes we have. So here we see it more clearly. The input node, the input layer has 4 nodes because we have length and width of sepal and petal. And then the output layer has 3 nodes because we have 3 classes. So now it's time to train the model. We will, for this, we first get the configuration. After that, we initialize the model. We set some listeners to get some log outputs of the score. And after that, we feed the model 1,000 times. Why 1,000 times? Well, this is a lot of times more art than science. I tried with 500, and the numbers were not better. And I tried with 2,000, and the numbers not better. I mean, the best I found was with 1,000 iteration. So now, in order to evaluate the model, we will use this class evaluation provided by Deeplearning4j, where we are gonna provide the test data set, and then it is going to evaluate how well the model performs. This is the kind of output that we can get. It gives us accuracy, precision, recall, F1 score, and confusion matrix, for example. And of course, we can use this evaluation metrics during integration testing or during any kind of automated testing that you are doing. And after that, we will export the model. We just create a file and then leverage the API from Deeplearning4j to perform this. And we also need to store the normalizer because we will need it on the next step to normalize the data in the same way. So now for the prediction step, we need to load the model, we need to format the data, we need to normalize it, feed it to the model, and then get the label. So let's look at the most valuable code. So here, we'll load the model. We just load it from the same file where we stored it in the previous step. And then we also load the normalizer. Now we have them in memory. Then we format the data. In this case, this iris that you see in the parameter is just a pollo that I created for manipulating the information. So we need to put this into an array in the right order, in the right indexes, and then we need to transform this into an ND array, which is the kind of arrays that Deeplearning4j operates with. So after that, we use the normalizer to normalize the data, and then we feed the data to the model, and then we get the result. The result that we get is an array with the probabilities of each label. So after that, we need to get which index has the biggest probabilities, and then we need to transform this into a label in our domain, let's say. So that's it. You could use this class, and you could, for example, wrap it into a REST API so that everyone on the internet could provide the measurements, and then this program will tell them what kind of flower they got. And hey, now Peter is happy because now his friends can classify these flowers just by providing the measurements using the flower classification API. So what did we learn in this rather simple story? There are two main steps in machine learning, training and prediction. The input of training is the label dataset, and its output is a trained model. Then on the prediction, you need a trained model and labeled data, and the output is the prediction, which in this case is a classification. We also saw how to use Deeplearning4j to train a model, export it, load it, and perform a prediction. So now, what are the different machine learning approaches that exist? There is supervised, unsupervised, and reinforcement learning, among some others, maybe. So in the supervised, you have classification and regression. The idea of classification is that you have your data set with a set of labels that you want to map. And then on the regression, instead of having these labels, you have numbers that you infer from the columns, from the data that you have. On unsupervised learning, you don't know in advance these labels. So the idea is that you use it to find relationships among the data. For example, different kind of clusters. And in reinforcement learning, the idea is that you have an agent interacting with an environment with a set of actions trying to maximize a reward. And Deeplearning4j supports all of them. Now, coming to the available algorithms in machine learning, there are a lot, but Deeplearning4j just provides neural networks, which are also known as deep learning, and well, from the name you can infer that, right? This is, from my perspective, this could be kind of a disadvantage of Deeplearning4j, because sometimes you can achieve the same or better results with simpler algorithms, but that's the way it is. So now, let's talk about the integrations. In order to perform distributed training, you have a native integration with Apache Spark and Apache Hadoop. You can also integrate with CUDA, if you have the GPUs available to do parallel training. And this is a cool thing. You just need to change the dependencies that you are using, and then you are using CUDA. And you can also import models from Keras. And I find this one interesting, so I will dig a little bit deeper into it. So first of all, I need to mention a little bit what Keras is. Keras is an open source neural network library written in Python, and it works on top of other frameworks or other tools, for example, TensorFlow. So let's go one step back. We say that we have the training step and the prediction step. And in the reality, in the practice, they are decoupled because you are exporting this model, and you are storing it somewhere. In this case, it was on the file system. And then again, during the example that we had, we were doing both things, the training and the prediction step, using Java. But now, what this integration with Keras offers is flexibility, because now you can use Python for doing your training step, and then you can use Java for performing your prediction step. So the idea is that this enables that you have different profiles of people working on this, because a lot of times the data scientists creating the models are more proficient in Python, so they are more comfortable using that. And then you have your software engineers, which are more comfortable using Java. Well, at least using this integration, you have this flexibility to have them in your team and to have them working on what they, where they shine the most. So that was it with the quick overview of machine learning and the basic of Deeplearning4j. Now we're going to look at the first example about image classification. So here we will leverage the model zoo that Deeplearning4j provides, and we will use also OpenCV for image manipulation. So yeah, as I said, Deeplearning4j provides a model zoo. This is a set of models that are already trained that you can just import. In this case, we're going to use YOLO2. YOLO2 stands for You Only Look Once. It's a cool thing. I invite you to have a look at their website. But at least here you can see an example, which is also in their website, of what YOLO2 is capable of. But the limitation it has is that it can just recognize so much things. These are all the labels that this particular version of YOLO recognizes. But in this case, we are lucky because these are exactly the kind of things that we want to detecting our images. So let's have a quick overview on what steps are required to solve this problem. So first, we need to load the model from the zoo. We need to load the image. We need to pre-process it. We need to feed this image to the YOLO model. And then we need to get the output, the detected objects. And after that, we need to annotate the original image. So let's have a quick look at the most valuable code. This is it. This is everything that what you need. Well, there is some other boilerplate code that you need, but this is the most important things. So as we said, first you need to load the model from the zoo. It's really that quick and easy. You just need a couple of lines of code. Then we need to load the image from the disk. After that, we need to resize the image and change the format to match the requirements from YOLO 2. And after that, we need to scale the image as in normalize the pixels to be in the range from 0 to 1. That's also required by YOLO. After that, we perform the classification. We feed this transformed image into the model, and we get the detected objects. This is a list with the label that it detected and the position in the image. So after that, we need to annotate the original image with this data. And we do that with OpenCV. So let's have a quick look at some of the examples that I came up with. Here, it detects a couple of motorcycles and a couple of people. I think it's impressive. It's nice. It was something easy to get, so it's nice. Here, it detects a couple of pairs of cubes. Also cute thing. Nice. Here, it detects a bird. Oh, here you see the label. It's maybe not the best coloring, but if you can see it detects a bird. And I find this one also cool because it just has the half of the bird and it still detects it. Now it detects a person wearing a backpack. And then here it starts to become a little bit weird because, yeah, it is detecting a couple of cars, so it's nice. They are on the background. They are, the second one is somehow hidden. And then it detects a person, but it also thinks that the tennis shoes are skateboard. So that's all right, kind of weird, but okay. After that, in this image, it detects two bears, even though there is just one. And this is gonna be my favorite because there is one bear, but it detects an elephant. So the lesson learned here is that YOLO 2 is really easy to use, really easy to learn, but you also need to perform a lot of tests in your use cases to make sure that it is actually detecting the kind of things that you are expecting. So now let's talk about the example of sentiment analysis. Here the approach is that we're going to take an example from the Deeplearning4j examples library, and we will modify it. And we will get a new data set from Kaggle. So this data set is public, is available in Kaggle. It contains, as you can see there, 1.6 million tweets. And it's annotated with whether they have a positive or a negative sentiment. The positive is 0 and the negative is 4. So this is the overview of what we're going to do, how we are going to solve this problem. So first, we need to load the word vectorizer. I will explain what a word vectorizer is. We need to load the data set. We need to clean the data set. We need to vectorize the words. We will configure the model, train it, evaluate it, and export it. So what does vectorizing words mean? The idea is that you need to transform the words into numbers that the model can understand. In this case, we will use word2vec, which is a two-layer neural network. It uses unsupervised approach. The input is a corpus of text, and the output is a vector space, where each unique word in the corpus is assigned to a corresponding vector in the space. It's, again, an interesting tool. I invite you to have a look at it. You can find different kind of relationships amongst the words. It's interesting. So let's have a quick overview of what the relationship is within the sentiment analysis. So let's say we want to analyze the sentiment of the phrase, "The talks at Devoxx Poland are awesome." So we feed this into word2vec, and then it will output numbers representing the words of the sentence, which then we will feed into the sentiment analysis model, and then the sentiment analysis model will tell us, yeah, the sentiment is positive. So let's have a look at the most valuable code. So first, we load the word vectorizer. In this case, we're using one from Google. It's already trained. But in the GitHub repo where you can find all the code of this, you can also find an example of how to train your own word2vec model because it is language dependent. So if you want to perform these operations in another language, you need to train your own word vectorizer, your own word2vec instance. So after that, we load the data set. We just go through all the lines, and then we extract the required data. This data set has a lot of other data that in this case is not that important. So we just extract the label and the tweet. And then as we are already iterating this, we take the chance to split into test and training. And here, well, with this, you can see that we will have the half of the data set for testing, for training, and then the other half for testing. So now, the next step is vectorizing the words, which is actually done behind the scenes by Deeplearning4j on this CNN sentence data iterator. We just need to provide the word vectors, which is the thing that we loaded earlier. And we also need to provide it the data, which is on this thing, training sentence provider. And here you can see that we got the training data and the label. So after that, we need to configure the model. I took this configuration from the Deeplearning4j examples, as I said, and they took it from a scientific paper. It is not that easy to come up with this kind of configurations. So in this case, we will just focus on the input and the output. The idea is that the input of this model needs to match the output of the words vectorizer. Here you can see what I mean, the thing that we mentioned earlier. Now we are on this, we are talking about this part and this part, the input. So, and then the output of this sentiment analysis model needs to have two nodes because we have two classes, either positive or negative sentiment. So after that, we will train the model. We set the different iterators. We feed it, we train it, we set also some listeners to get some updates on how the training is going, sorry. And then we export it to a file. So an example here is, this code is driving me crazy. What is this guy thinking? Annotates the code, oh, it was me. So the idea here is that it is more negative than positive, so we will take it as a negative sentiment. So now let's talk about what problems I had during the development of this last example. I had slowed feedback during the beginning of the development because taking almost 2 million of tweets, it's a lot. So it took a lot of time to load the stuff and to train it. And I couldn't iterate fast enough. I also had memory management issues because of the same thing. I was loading too much data. And I had also some problems loading the data set, parsing it from the file into memory. So let's have a look at the solutions. So in order to get faster feedback at the beginning of the development, I made some sampling. So instead of using these almost 2 million of tweets, I got 1,000 examples from the positive and 1,000 examples from the negative. And then I was scaling the size, and I realized that even though in one execution I had 40 times more samples than in other, the execution time was just 10 times faster. So this caught my attention. I got curious about it. So I dug deeper into it. And I found out that the problem, the culprit, was loading the word vectors. Out of the 2.75 minutes that the execution for 2,000 samples was taking, almost 2.6 minutes was just loading the word vectors. And there is nothing you can do about it. Well, maybe you can get also a smaller word vec, but in this case, I just kept moving. And then, in order to solve the memory management issues, I had to tweak a couple of JVM parameters. So I had to tweak the one for the initial memory allocation pool and the one for the maximum memory allocation pool. This is actually suggested on the official Deeplearning4j website. And there you can see more suggestions on how you can tweak your Java virtual machine. And then also during this development stage, I found that on files bigger than 40,000 lines, the class Java util scanner will read just up to the half of the file. And this was messing with the training later. This took me a couple of hours to figure out because I don't know whether I was doing wrong configurations or what was going on. I never expect having such a problem with Java util scanner. So what I did is I just changed that for the file utils line iterator from Apache, and then it started working again like a charm. So that's it. What we saw today, we saw some basics of machine learning and what Deeplearning4j is. We saw some integrations of Deeplearning4j. We saw a couple of hands-on examples on how to perform image classification, and sentiment analysis. And here you can scan this QR code to get all the relevant links to my Twitter, my email, and most important, the code, the GitHub repo. So thank you very much. As I said, you can check the code that this repo in GitHub, and there are also some blog posts about this at my blog at ienjoysoftware.dev. Thank you very much.